Hey everyone, thanks for joining. My name's Omkar. I run the data platform team at Flipside. Figure before we jump in and give you a quick introduction as to what Flipside does, what we're all about, why we exist, and then jump into the meat of the presentation. We'll be talking about how our data platform works, how our data gets from on-chain on the node into the hands of users, and then how we build tools for our architecture. Our operations team's lives a little easier. And this is where we'll spend the bulk of our time. And then we'll leave some time for questions and answers. So quick overview of Flipside and what we do. Our goal is to build an open data platform that allows crypto users, communities, ecosystems to really dig into data in a free and open way. You know, we're all about making sure that this data is structured, it's accessible to all types of users, with like someone who's just starting out and someone who's incredibly advanced and knows their way around every single piece of data. And our goal is to provide analytics and answers to popular questions that are coming up in the ecosystem. And we do this through a program called CEA, Community Enabled Analytics. We reward analysts with crypto bounties for the work that they do in the form of analytics bounties. So the community might ask a question, hey, what happened with my anchor airdrops? We would bounty that out, someone would answer the question, and we would pay them out. Scavenger hunts are really helpful for users getting involved in the ecosystem. It's called like a pre-fight checklist before you dig really into the data to understand the bits and pieces that make the data useful and how it's structured, and the ecosystem at large. What happens on Terra that makes it so unique and so interesting? And the last one, and probably my most favorite, is data cheat codes. Our power users help us build analytics and build these models to add leverage to the platform. So analysts aren't reinventing the wheel every single time they come in. These types of models help, take the analysis that we're doing to the next level, to the second level, and really drive even more detailed analysis of like these questions that people are asking. So that's kind of what we do and what we're about. Again, it's just an open data platform that's committed to providing on-chain analytics in a structured and labeled way to make it easy for access. So I figure, we'll talk a little bit about how what our architecture looks like and how we structure our data. So at the core of it, we have our nodes. We've parsed over 60 different nodes, or we've parsed over 60 different chains and pulled that data in. The three we spend the most time on right now: Ethereum, Terra, obviously, and Polygon. Spending time across these other chains helps us answer unique questions about cross-chain analytics, right? Like if someone's moving money from Ethereum onto Terra, if you're just focusing on Terra, you kind of lose that person once they move from Ethereum to Terra. And by combining these data sets, we really allow people to do that cross-chain analysis. So this data is on these nodes. We've built a tool a couple of years ago called Chainwalkers. What Chainwalkers does is it pulls the data down and indexes it. This indexing allows for easier retrieval downstream. These nodes aren't built for read writes, so reads are especially slow. We want to pull that data down for easy local access. And part of a lot of events are on chain. You can see swaps and transactions and stuff, but the thing that's missing on chain at the event level is what I like to call context. Like, what's the world view of the data at that point in time? So you might see that there's a swap happening, but who's doing that swap? What's the price at that point? What's the balance of the address? all of these things you can't see from on-chain data at the event level, at least. And so what we do is we provide a layer of data augmentation. I call it state data because we're pulling in balance data. What's the state of that address at that given point in time? How much money does it actually have in its address? Then we pull in, what's the price? What's the price of an asset at any given time? If you're looking at like one of the things that we'll pull in is like liquidation prices. What's the liquidation threshold for a leveraged position? This type of information isn't really captured at the event level, so we have to pull it in especially. And then our data science team spends a lot of time with labels. Understanding the behaviors and the actions of the actors in the ecosystem. This helps us add like another level of depth and detail to the analysis that we're able to provide and the data that we're able to provide to the community. It's not really helpful knowing that 10 addresses are transferring back and forth if you can't tell that they're arbitrage addresses or arbitrage bots rather. Or, it's maybe a centralized exchange that's making a transaction versus, oh, this address over here is a DEX. So the data augmentation layer specifically is designed to add context and add a worldview to the data that otherwise doesn't really have one. It helps us make sense of this data. And after this data has gone through this augmentation layer, what happens is the data gets into the data modeling step. The data modeling step is probably one of the most critical pieces in order to make this data structured and accessible. The data analytics team that we have and our analysts at large spend a lot of time with the data, understanding the nuances of how it works. So, the data on chain comes off and it's raw JSON and you're looking at it and you're like, what in the world am I looking at? The analytics team is looking at that type of data all day. And they're the experts on what this data should look like and what the different events look like. And so they'll take this data, they'll take the augmentation layer, the state data, the balances, the labels, the prices, all of that other stuff that's so critical to understanding the data, and then they'll put it together in a way that makes sense. So they'll pull up the swaps, add the prices, add the balances, and say, this really particular address was doing a swap at this particular point in time, and his balance changed from X to X, or X to Y rather. And this data modeling layer allows analysts from the community to come in and say, oh, wow, I can look at this data and without having to, reinvent the wheel, start from scratch, start from the JSON, look at this data and say, okay, this is the question that I need to answer. This is how I'm going to answer it. And at this point, I'm going to jump in, if my computer allows me to, into how we actually write this. So as I said before, the data comes into our warehouse. It's a Snowflake warehouse, and it comes into our warehouse in a raw JSON format. And this raw JSON format is incredibly difficult to work with in a relational manner. So the first step in the process is our data analytics team takes this data and decides what's the business rule behind it. And so you'll see at the top here on line 4, the analytics team has decided that the chain ID, specifying that this is Terra, this is Columbus 4, the block ID, the transaction ID, the message index, and in this case the event index, are the key parts of this particular message or this particular event. And so they'll take this raw JSON and classify it and structure it and say, this should be a string, this should be an integer, et cetera, and make a base set of tables that then analytics can build. We can build analytics on top of. And so we do this for every single type of event that comes through our system. So if I go back one level, you can see we've got, let me actually go back even further one level. So we got this data for Ethereum, for Polygon, for Terra. for Thorchain, but the crux of it is the same. You take the raw JSON, and then you structure it. You turn it into a readable format that people can then build on. So this is the part that really adds a ton of leverage. Okay, so now we have this this structured data. What do you do with it then? Well, we talked about a little bit about the business rule in this case. So we've got the chain ID, the block ID, et cetera, et cetera, et cetera. Every layer we get more and more specific about the type of data that we're looking for. So in this case, we've decided that we're going to parse out message events. Message events are an event in transactions. You can have regular events, you can have message events, like you can just have transactions. And so in this case, we're saying, okay, we're going to look at message events specifically. And with any sort of streaming-based platform, you're bound to end up with some duplicate data, some a range of data. The data doesn't come in like a continuous structured manner. So this step is really critical to harden the data set to make sure that we're not delivering duplicate data or missing data to our end users. And in this case, what we're doing is saying, okay, well, we might see 2 or 3 records that have the same unique key, but we're going to make sure that we only grab the latest one because we know that's the right one. And I just want to call out for those who know SQL, this is a really, really fantastic function that I've learned about recently that our analytics team taught me about. It's called qualify. In a standard way of doing this, you might write a subquery with a window function and then say, partition over the chain ID where row equals 1. In this case, qualify can take a filter and a function. So our qualify function statement here takes a row number function and a set of partitions, in this case our business key, orders it and then says, okay, I'm going to grab the one that was inserted the latest. Okay, so now that data's in our tables, it's to the layer of granularity where you can start understanding it. You're not dealing with duplicates, you're not dealing with any missing data. Now you're ready to say, okay, what am I actually going to do with this data? And now you can go in a number of different ways. What we've done is taken a step back and said, okay, what are all of the different things that we care about in this ecosystem? And so stepping back, what we've done is said, okay, the message, in this case, the message event contains or can contain, deposits, authorizations, grants. It can contain transfers. It can contain swaps. That's a lot of data to parse through. It's a lot of information to unpack, especially if you're just getting started. So what we've done is try to make it incredibly simple for a first-time user to step in and say, well, okay, I know my way around the ecosystem. I know that I'm looking for market swaps, for example. And so the user, rather than having to say, okay, how is that market swap event structured? Where should I go look for it? We've done a lot of that work, and we've said, okay, we're going to take that and structure it and augment it and add context to it and deliver it as a new table and say, okay, this table is now the market swaps table. So you can see that we've filtered out the messages that aren't swaps and filtered out where you might be seeing simple transactions, and focused in this specific table on just market swaps. So you're not, in this case, the user isn't seeing anything other than specific swaps. Oops. And so that's kind of how we maintain a level of structure and a level of depth, while also making all of these tables really easy to access. And what's cool about this is a lot of these tables are completely open for use as well, like the raw table. So if you are a power user and you want to see the raw unstructured message events table, it's there for use as well. And actually, all of these models are open and are available for use. If you go to Flipside Crypto and look for SQL models, our analytics team is building all of these models in the open. So go in there, take a look. We'd love any input. The other really fascinating one that we do is the balances table. Balances, in my opinion, are one of the most critical pieces to understand, are one of the most critical pieces of context to understand. It's not enough to say, address X transacted to address Y, but how much did they have before? How much did they end? Did they move all of their money and now they're left with zero? Or are they just moving like a small sliver of their tokens? And this is a really interesting query because you can see how we're pulling in prices from our Oracle prices table that we've generated. We're pulling in balances that we've been capturing along the way. And we're augmenting them with our labels that you can see here. So this table is like the crux of the initial event, taken, like, augmented with a balance, added labels and prices, and then delivered to the user where they can say, show me the balance of Binance at a given point in time or across a range of days. And this type of analysis is really helpful for understanding at a base level, is money flowing into a system? Is money net flowing out of a system? What are people trying to do? And so, all of these put together provide this like big open data set for users to interact with and to drive queries with. I called out the anchor one originally, but that one it's a really fascinating example of pulling all of this together, combining Ethereum data, and seeing how ETH goes to staked ETH, goes to BETH, transfers over to the Terra ecosystem, is deposited in Anchor, and then what happens to that collateral afterwards. Our data science team did a fantastic job of putting that analysis together using all of these different elements of this pipeline. So that's kind of how our data system works. And how does that relate to our bounty infrastructure? So this data powers our bounties. Analysts are answering these questions, submitting really fascinating, fantastic analyses. And our ops team has a huge task in front of them. And that task is basically go through all these submissions, make sure they're answering the questions, make sure the people asking the questions are satisfied, and then paying people out. So, last week we got over 200 submissions, which resulted in 50, 60 to 100 different payments out to users in a given week. And, without a structured or an automatic way to do that, it's really difficult for our ops team to keep up with the flow or with the volume of demand and with the amount of transactions that we're having to do in a given week, in a given day. And for us, like, transparency and reliability is of utmost importance. It's critical. So when you're having to do 60 transactions, 80 transactions, or even hundreds of transactions in a day, and trying to make sure that each one of those is exactly right and goes through the right audit process, it's a very time-consuming process, and it makes our turnaround to paying people out extend much further than we'd like to. And so to that degree, we built a tool for our finance and ops team to use. Come on, load, buddy. For our finance and ops team to use to build, to automate this process and to automate this payment process for them, this audit process, this payment process, and this reconciliation process. And this is the tool that we'd love for you to reimagine. Like, what's a better way for us to deliver this tool to the community? This tool, we're in the middle of open sourcing. We'd really like to get this into the hands of the community and into the hands of our ops team, but also any team that could benefit from a tool like this. I've been rambling for a minute. I'm going to stop and make sure that I'm answering questions. Here we go. Are Chainwalkers open source? Our Chainwalkers are open source. We have a number of Chainwalkers that we've opened up. You can go to our GitHub repo, look at our Ethereum Chainwalkers. We're in the middle of open sourcing a number of other Chainwalkers as well. First Coast Crypto is asking, what would I use that data for? To my earlier point, it's basically about answering questions and understanding the differences between understanding what's happening on chain. This data is really hard to get at if you don't have all of the infrastructure set up, and so we're making it very easy to use. So actually, I can pull up an example of what a data set looks like. Let me see. I'm frozen. So let's see. So this is a console we've built internally that uses our data, but it's helping helping provide an overview of the ecosystem, right? It's understanding what users are doing on chain, what types of tokens, what types of activities are happening. What should Anchor be thinking about? What should Mirror be thinking about? What should Pylon be thinking about? What should all of these protocols be thinking about? It's really hard to answer these questions without the appropriate data sets to answer those questions. And further to further underscore the point, like why is the bounty program so important? All of this has to be done in-house right now, and in the spirit of the being open with our information, it's really important that the community be engaged in the understanding of these systems, in the development of these systems, and in the furthering of these systems. So you can't really participate in informed discussion without first understanding what is being discussed. And so this part of our key thesis is you need to educate the core user base of what's happening on chain, so that they can be armed with the tools to further these ecosystems. Let's see. Okay, so into the Terra multisend, want to spend some time talking about that. This is the tool. I'm frozen. This is the tool that I really want to spend some time talking to you guys about. The multisend tool we built for our finance team to make sure that they have the right tools to automate a lot of the manual work that they're doing. And just talking through kind of how this works, we have a basic CLI tool. I'm really lucky that our finance team is incredibly technical and can work through this and install this. And I can tell them, run this command in the terminal, but not everyone is so lucky. But what we do is the finance team gets an Excel spreadsheet of all sorts of different transactions, or all sorts of different addresses that are owed bounties, or that are owed their winnings. They have to then take those and then pay people out. So what we've done is automated the pay people out part. This Excel spreadsheet, they turn into a JSON format that looks like this. It's got the recipients with a certain amount of tokens in them, and then the senders, which is us in this case. And then we set up a mnemonic to make that to allow for that transaction. So those are the two things that they need to configure. So jumping into how it works is the finance team configures those two files and says, okay, first I want to validate that these files are correct. So we'll go in and we will basically just run through all of the senders, which usually is just us, and say, or is usually just one of our addresses rather, and say, does that amount that we're expecting to send out match the amount that everyone is expecting to receive? And that's a really easy way to just validate that we haven't fat fingered something. Someone isn't going to get 1 Luna instead of 10 Luna. Would be a real bummer for them. And we want to prevent that from happening. So first step, validation data. This is like a key thesis for all data that we run through. But the first step is to make sure that what you're sending is correct. Then we say, okay, we're going to take this validated data and we're going to construct it into the appropriate inputs and outputs. In this case, our team just pays out in Luna right now, so we've hard coded in a Luna conversion and said, okay, these are the inputs and these are the outputs. And then we take that message and we construct it into a multi-send message. And then we define a set of fees. Usually fees on one of the fantastic things about Terra is the fees are super low. So we've constructed a fee that we know always works, and we say we're going to pay. In this case, I think what is this, like 20 cents worth of fee in order to push these transactions through. And after the transaction is pushed through, we broadcast the transaction and deliver it to the end user. All of these transactions are batched into one big transaction and then delivered to the user rather than sending out 60 or so different transactions. This turns the turnaround time to delivering these payments is a lot faster, and the tools and everyone's happier in the end. Major callouts here that I want to bring up is, like I said before, our finance team, thankfully, is very technical. Not everyone has that luxury. So making this a lot more user-friendly so that there's a web UI or an Excel upload that delivers these payments would be a real win. Adjusting the fee so we're not always paying out in the same fee, and then obviously, you want to send more than just Luna tokens. So having the right conversion, allowing for all those different conversions and those different currencies is another really big way to advance this little tool and turn it into a full-fledged product. So that's the big piece of the crux of the presentation that I had prepared today. We'll leave some time for questions as it comes in. Okay, let's try this. Okay, I think that's better. Okay, any questions? I think that's it then. Either that or I'm frozen. Thanks, guys.